Hi, this is a lecture on chapter 14. Basically, this chapter is called Firms and Competitive Markets. Okay. And the goal of this chapter is to introduce to you uh, your first view or introduce to you your first kind of real look at how a market works. And what I mean by that is how firms sell stuff in a particular marketplace. In this chapter, we're going to study a very specific market called a competitive market or a perfectly competitive marketplace. Okay, I'm going to use competitive market and perfectly competitive interchangeably. The learning objectives for this chapter is to define to you what is a competitive or perfectly competitive market. I have to tell you what it is, under what assumptions does one exist. What is this thing called marginal revenue and how it's related to total and revenue and average revenue? How does a competitive firm determine the quantity that maximizes profit? Basically, how does a firm decide to make the most money possible? Then we're going to go into what I call Taco Tuesday land. When might a competitive firm decide to shut down in the short run? In the short run, decide, you know what, it's better not to just produce anything. We'll just shut down in the short run. Or decide to produce at a loss. That's what I call Taco Tuesday. And in the long run, exit the market. So you know what, this is not worth it. We're in the long run. We'll just leave. Lastly, what does the market supply curve look like in the short run as well as the long run? Okay, so that's what we're going to cover. There's a what I call the more difficult supply and demand model that's attached to this chapter 14. We will not do that. I'm going to end this chapter before I get to that quote unquote more difficult supply and demand. We will learn that after we learn the easy supply and demand, which is the next lecture. Okay, once we learn that, then we will go back if we have time. All right. Okay. A competitive market. Okay. This is the benchmark of efficiency. Okay, well, we will find that this is the benchmark of efficiency that all other markets are examined against. Okay. In this idealistic competitive marketplace that, and I'll tell you in honesty, in real world, likely this true perfectly competitive market doesn't really exist, only in very specific situations. This is what we're going to bench other markets that we're going to learn about against. These other markets that we're going to learn about are monopolistic competition, oligopoly, and monopoly. We'll do that later on in this semester. All right, so let me go into what makes a market perfectly competitive or competitive. Okay, so what are the characteristics? Let's list this now. Okay. Again, competitive market and perfectly competitive market are interchangeable. In a competitive market or a perfectly competitive market, it is a situation where we have bazillions of buyers and bazillions of sellers. Okay. Think of the swap meet. Okay, you have many, many people that are trying to buy something very simple and many, many people that are trying to sell something very simple. The simple product we're going to say is all the sellers and buyers are trying to buy and sell this identical generic product. Okay, it's an identical generic product. Think of like tube socks or white t-shirts. We're going to say each buyer and seller is very tiny because there's billions of them out there, and they're quote unquote price takers. I'll explain that shortly. We're going to say firms can freely enter and exit. There's nothing stopping them from coming into and selling this generic product. It's not like trying to sell Apple iPhones. Apple has a trademark. They're the only ones who could sell iPhones, or Samsung Galaxy phones. Samsung has a trademark. You cannot, even though you could hire people to backwards engineer an Apple iPhone or Samsung Galaxy phone, etc. You can't do it legally. You'll get sued. Generic white t-shirts like this, you buy from the same Chinese, Vietnamese factory that everybody else buys from. And you go set up a little store at a swap meet and start selling it. Okay? There's nothing preventing another seller from coming in. And then on the flip side, there's nothing preventing a seller from just leaving. Okay? All right. So why are you a price taker? Why are buyers and sellers price takers? It's because of this. There's bazillions of buyers and sellers. Let's suppose at a swap meet, there's a bazillion people that are trying to buy and sell white t-shirts. Let's suppose the going price of the white t-shirt is $10 each. Okay. If everybody is selling white t-shirts for $10 each, every seller is selling white t-shirts for $10 each, and there's billions of people lined up at their stores, $10 each. If I go in there and I try to sell for $11 each, no one's going to come to me. There's a billion other stores next to me selling for $10 each. Why would anybody come to me? Now let's look at the flip side. Okay, so and that's a situation why a seller is a price taker. Now let's look at the flip side. Why is a buyer or consumer a price taker? There's billions of stores. They're all advertising at $10 each. Okay, and then remember, there's billions of buyers all trying to buy at $10 a white t-shirt. If you try to go there and try to haggle for $9.50, $9 a white t-shirt, the seller will say to you, can you please step aside? There's 10 guys behind you, more than happy to buy it at $10 each. Please leave me alone. Go away. No one will sell to you. Every buyer, every seller is quote unquote a price taker. All right. So now let's go into how a competitive firm decides to produce in this type of situation. Okay. Oops. Okay. If you remember from the previous chapter, chapter 13, competitive firms decide production levels. How do they decide? Well, they decide how much to produce with the firm's goal in mind. Remember, the firm's goal is to maximize profits, which is total revenue minus total cost, and they maximize profits by selecting quantity. That's how they pick it. Okay. What we are going to do now is think about what total revenue looks like for a perfectly competitive firm. Okay. For a perfectly competitive firm, we have total revenue is equal to price times quantity. And I said the price is given to this firm. Okay, so it's a number. $5 a white t-shirt, $10 a white t-shirt. It's given to the firm. All right. So then from here, I'm going to give you two extra definitions. We're going to give you average revenue. What is average revenue? This is just total revenue divided by quantity. This is the per unit revenue. How much are you making per each white t-shirt? Well, this is price times quantity divided by quantity. It's just the price. Okay. And the next thing we're going to talk about is MR, which is marginal revenue. Okay. Marginal revenue. Okay. This is the change in total revenue by changing quantity by 1 unit. So I'm making whatever. I'm selling white t-shirts. And then I decide to sell one more white t-shirt. So I decide to increase Q by 1. Well, how much does total revenue increase by? That means I sell one extra white t-shirt, total revenue increases, increase total revenue by marginal revenue, which is P. Okay, so the marginal revenue is just P. P divided by 1, or just P. What we see here is that price, the given price to the firm, is equal to average revenue, and it is also equal to marginal revenue. Okay. All right. So how does a firm decide to pick quantity? Well, we didn't get into that yet. I was just giving you definitions right now. So let's get into that. Okay. I'm going to first assert or just tell you how they do this. And then I'm going to prove it to you. All right. So what a firm does is they pick Q to max profit, which I've already shown up here. Pi is for profit. This is profit. And they do this by comparing marginal revenue with marginal cost. What is marginal revenue? It's the extra revenue you gain from producing one extra when you change quantity by 1. What's marginal cost? It's the extra cost incurred by changing quantity by 1. If marginal revenue is greater than marginal cost, quantity should go up, right? By producing one extra unit, marginal revenue is greater than marginal cost, meaning I will make a, let's say $10, but it only costs me $5 to make it, that extra one. Then I'm making $5 extra in terms of profit. Yeah, you would do that. If marginal revenue is less than marginal cost, then marginal quantity should go down. So firm, what they do is they compare marginal revenue and marginal cost. And if marginal revenue is greater than marginal cost, they produce more. Marginal revenue is less than marginal cost, they decide to produce less. They tweak that stuff until when marginal revenue is equal to marginal cost. Okay, when that is true, okay, look at Q where this is true. Okay, this Q maxes profit. That's the Q that maximizes profit. Okay, where marginal revenue equals marginal cost, that's the quantity that maximizes profit. One last thing I want to show you is, remember, marginal revenue is equal to average revenue is equal to price. So price is equal to marginal revenue, it's equal to average revenue, is equal to marginal cost. When we have max profit, or we have marginal cost pricing, where price is equal to marginal cost when we maximize profit. Okay. What that basically means is that the price they end up charging equals the price per unit equals the cost it takes to make that extra unit. Okay. All right. So let's talk about this. I said to you that you pick the Q that maximize profit, and that happens when marginal revenue is equal to marginal cost. I just asserted that. Now I'm going to prove it to you. All right. All right. Let's prove this. So the way to prove it is I'm going to draw a graph, and I'm going to have Q quantity, and up here I'm going to have total cost and total revenue curves. Okay, the total cost curve, if you remember from the previous chapter, it looks like this. This is total cost curve, increasing at an increasing rate. The total revenue curve looks like this. Okay. This. Let me move this one. Cost. Oh. Total revenue. Remember, total revenue is equal to price times quantity. Total revenue is measured on the y-axis. Quantity is measured on the x-axis. This is y equals mx plus b, where b is 0, y-intercept is 0, m is the slope, which is equal to the price. So the slope of this is equal to price. Okay, that's how you could see it's a straight line coming out of the origin. Okay. Now from here, I can mark some points. We have this point right here where total revenue and total cost hit, and right here where total revenue and total cost hits. So right here, draw a line down, and you have some Q, I'll put 1, and we have another point here we'll call Q2. At those 2 points, that's where total revenue equals total cost. When total revenue equals total cost, profit is equal to 0. Remember, profit is equal to total revenue minus total cost. When these two are equal, profit is equal to 0. So here and here, profit is equal to 0. Profit is equal to 0. All right. Let's mark some other things on here. Okay. When we go to the left of Q1 and to the right of Q2, we see total cost, let's say right here, at let's say Q3. Total revenue is down here and total cost is up here. So total cost is higher than total revenue. Or when we go to the left of Q1, profit is less than 0. And when we go to the right of Q2, profit is less than 0. So you have net losses in this region right here and in this region. All right. What about in between Q1 and Q2? Let's just pick a point, Q4. And we could see this is total cost, this is total revenue, this vertical distance measures profit. That's greater than 0. It's positive profit. And you could see it starts from 0, gets bigger, 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 bigger. And at some point, I don't know, like right around here, It's the biggest, and I'm going to do Q star. And then after that, it gets smaller, 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 back to 0. So somewhere in between, I don't know where, but somewhere in between, maybe around here, we have max profit, the highest profit. And I'm going to say that's denoted that with Q star. At this point, okay, we have right here the slope of total revenue. Okay, we said that's the price, but we also said that is equal to marginal revenue. Okay, remember price is equal to marginal revenue, which is also equal to marginal cost. So the slope of here is the price or marginal revenue. Slope of the, how do I know that? It's the rise over run, or change in total revenue divided by change in quantity, that's marginal revenue. Remember, rise over run. Here, total cost, slope of total cost, well, that's anywhere, is equal to rise, change in total cost divided by change in quantity, which is marginal cost. And what I'm going to assert, I haven't proved, is when profit is maximized, this slope right here equals the slope right here. They both have the same slope. Okay? Or marginal revenue equals marginal cost. I haven't proved it. I just asserted it. Now I will prove it. Okay? I'm going to go down and draw another curve right down here below that one. But Q, and I'm going to draw profit from now on in this two-dimensional world. Okay? So let me do this. And we have 2 points right here, Q1 and Q2. At Q1 and Q2, profit is 0. So it hits right here at the x-intercept. To the left of Q1, to the right of Q2, profit is less than 0. So it's below the origin, below right here. It goes down, it goes down. And then in between Q1 and Q2, profit goes from 0, it goes up to some point right here. It's the highest. Okay, Q star, it's the highest. And it goes back down. So it's like a hump shape. The highest, and it goes back down like that. Oh, should have drew it better. Like that. So right here, it's the highest. At the peak, the slope is flat. Okay, right here, at the peak of this hill, peak of this hill, the slope is flat. When you have a flat slope, the slope is equal to 0. Okay, when you're at the peak of the hill, the slope, when it's flat like that, slope is equal to 0. All right, so what is equal to 0? That's rise over run. Rise is change in profit divided by run, change in quantity. I could extend this out. Profit is change in total revenue minus total cost divided by change in quantity. Let's write it up here. Oh, no, I don't have to do that. This is equal to change in total revenue divided by change in quantity minus change in total cost divided by change in quantity. That is equal to 0. Okay, so I'm going to rewrite this one up here. Well, remember what this is. That's marginal revenue. Remember what this is. Minus marginal cost is equal to 0. or marginal revenue is equal to marginal cost. Because I could put this on that side. So what does this mean? At this peak profit point, where profit is the highest, the slope is equal to 0, and we just derived that's where marginal revenue is equal to marginal cost. Okay? Firms, this is why they choose a quantity where marginal revenue is equal to marginal cost, because at that quantity, we have the max profit. All right, that's kind of important to know. Remember that. Remember, max profit is when marginal revenue is equal to marginal cost. That's how we pick quantities. Okay, and this is going to be true for many cases that we're going to go learn about going forward. Monopoly, monopolistic competition, etc. Everybody looks at marginal revenue and marginal cost to pick quantity because we know that's what maximizes profit. All right, I'm going to clear this and move on. All right, let me show you a graph of profit maximization. Okay, so let's draw that. Okay. A typical graph of a company in the short run that's trying to maximize profit. And I'm going to give you two scenarios. A scenario in which a company is making positive economic profit, and a scenario where a company is making negative economic profit or losing money. Okay, so let's talk about these scenarios. The first one, let's go scenario 1. Your profit is greater than 0. So I'm going to draw a graph. You have quantity and dollar sign. First, I'm going to draw the quote unquote supply side, how a firm decides to make to set up their business. Given that a random firm decides to set up a business a certain way, we have an average total cost curve, an average variable cost curve, and a marginal cost curve, 2 U's and a J. This represents a firm and its, way of setting up the business. When it decides to open up for business, let's call this the pizza business. It bought a particular type of pizza oven. It bought a particular type of dough based on grandma's recipe, and it decides to open it for business. And it's a price taker. Price is given to them. Opens up for the business, and the price, which is equal to marginal revenue, is equal to also average revenue, is up here. And let's say it's like $5 a slice. All right. Where marginal revenue hits marginal cost right here. Okay. Go 90 degrees down. And that's the quantity it decides to produce. Let's call that, I don't know, 10 slices of pizza. So what is total revenue? Total revenue is price times quantity. $5 a slice. They make 10 slices. They make $50. Okay. So total revenue right now is $50. Okay. So now let's figure out, well, what is this company's total cost? Because we want to try to figure out the profit for this company. Well, we go down and we see where it hits average total cost right here. Right here, this point, this is average total cost. And we'll say, well, that's something below 5. We'll make it simple and stupid and call it 3. Okay, Well, remember, average total cost is equal to total cost divided by quantity. So total cost is equal to average total cost times quantity. All right, so the total cost is equal to average total cost, which is $3 each, times quantity is 10, 30. All right, so profit is equal to total revenue minus total cost. 50 minus 30 is 20. All right, so what does that look like visually? Oh, 20. You know the profit's 20. So what does that look like visually? Well, this vertical distance right here from the origin to average total cost, that's 3. Horizontal distance right here is 10. 10 times 3. So the area of this box is total cost. This vertical distance right here is 5. This horizontal distance is 10. So the area of this red box is total revenue. The difference of these two right here, that is profit. In this case, total revenue, the red box is bigger than total cost, the kind of a red-brown box. We have profit is greater than 0. Okay. All right, now what I'm going to do is show you a situation where a company is losing money. Okay. Clear this and show you scenario 2. So we have quantity. We have $sign because I'm going to give you, 2 U's and a J, and the price, they're all measured in dollars. So 2 U's, average total cost, average variable cost, and a J, marginal cost. That's the structure of the business. It decides this is another pizza store. Okay, the other one was whatever, Papa John's, and this is Domino's. Domino's decides to open for business and they picked a certain way of doing its business. It picked a certain pizza oven, certain recipe based on their grandma, whatever. And they had this type of cost structure: average total cost, average variable cost, and marginal cost. They opened up for business. And then boom, that's the price. Price is equal to average revenue, and it's also equal to marginal revenue. So when marginal revenue or price hits marginal cost right here, draw a 90-degree down, that's the quantity that it produces. Let's say this is $5 each, and they also make 10 slices of pizza. So this company, remember, profit is go to total revenue minus total cost. Total revenue is price times quantity. It's 5 times 10, or 50. All right, so let's see. Okay, so this black box right here, well, that's total revenue. Well, what about total cost? Total cost, remember, is average total cost times quantity. Okay, at this quantity of 10, average total cost is all the way up here. Right there. That is average total cost. It's a number greater than 5. Let's just be simple and stupid. Call that 6. 6 times 10, remember this quantity is 10, 60. So this red box measures total cost. That is 60. Profit is equal to negative 10 in our situation, which is less than 0. 50 minus 60 is negative 10. Okay, how is that denoted here? It's this shaded region right here. It's a loss. profit less than 0. So now I showed you two scenarios and how to find profit maximizing quantity. One scenario, the company is making money, positive economic profit. In another scenario, the company is losing money, negative economic profit. Okay, so now what I'm gonna do is go to the next topic. And this next topic, let's see what it is. Okay, measuring profit. Sure. All right. All right. Next thing we're going to do is talk about the short run decisions for a company. Okay. So let's do this. Okay. So for a firm, what I'm going to assert to you is the following. Let me draw this out. Quantity, $, average total cost, average variable cost, 2 U's and a J, marginal cost. What I'm going to assert to you is the following. This shaded region right here. Starting right here. Okay. For a firm in the short run, their supply curve is the marginal cost curve that's greater than or equal to average variable cost. So for a firm, if the price is in this region here, above this point right here, okay? So I'm going to put P lower bar right there. So as long as the price is in this region right here, price, the firm will produce, and they're going to produce in accordance to the marginal cost curve. How do I know? Well, let's just pick a thing right here. Price right there. Remember, that's marginal revenue. Where marginal revenue hits marginal cost, right there, this is how they decide to produce. Price is up here, or remember, that's also margin revenue. When it hits the marginal cost, this is how they decide to produce. This is how much they decide to produce. This is how much they decide to produce. Okay. Wherever the price is, it hits the marginal cost curve, and we figure out production. So the marginal cost curve is effectively the supply curve. Okay. But it stops right here, where marginal cost goes through the average variable cost. Right there. That's where it stops. Anything below that, if the price goes below that point in this region, the firm shuts down. Okay. So if the price, so the shutdown the short run shutdown rule is if price is less than average variable cost and you multiply both sides by quantity, total revenue is less than variable cost. Okay, quantity produced by the firm is equal to 0. They will shut down. If price is greater than or equal to average variable cost, then the firm sets Q based on marginal cost curve. Okay, the marginal cost curve. Okay, so now let's go talk about a specific region here, which I call the Taco Tuesday region, where a firm is losing money, but they will still produce. Okay, let me clear this. Okay. When the average variable cost is less than or equal to price is less than average total cost, the profit is actually less than 0. The company is losing money. However, the firm will still produce. Why? Because you are still doing better than shutting down. You're eating into some of your fixed costs and your losses are lower. It's like this. Let's say your rent, your fixed cost is like your monthly rent. You have to pay it regardless whether you produce anything or not. So let's say that's $1,000 a month. If your rent is $1,000 a month and you shut down, you're losing $1,000 a month. But let's suppose if you just stay open that month, you could make enough to cut into some of your rent. So you're only going to lose $600 a month. Well, you would do that because losing $600 a month is a lot better than losing $1,000 a month. And that is this region here when price is less than equal to average variable, greater than equal to average variable cost, but less than average total cost. And I'll show you visually what that region looks like. Here's quantity, $, average total cost, average variable cost, marginal cost is the J, it goes through the bottom of each point. So let me go through all these scenarios. Okay. Right here are the important ones. Okay. This region here is when the price is in between that region, your profit is less than 0, but quantity is greater than 0. You still produce. This region right here, okay, profit is less than 0 and quantity is equal to 0. That's the shutdown region, okay? Anything up here? Well, let me see it right here. At this point right here, okay, profit is equal to 0. And of course, quantity is greater than 0. Right here is when price is equal to average total cost, profit is equal to 0. This region right here, price is greater than or equal to average variable cost, but less than average total cost. You have negative profits, but you still produce. This region down here, where price, okay, is less than average variable cost, okay, your profit is less than you're losing money, and you decide to just shut down. It's just too not worth it. And all this region up here, your price is greater than average total cost and profit is greater than 0. So that's how you could break up this graph into different regions for production. Okay. Anything above where price is above greater than or equal to, okay, average variable cost you produce. This is, you're making good money. Right here, you're breaking even. Right here, you're losing money, but you're still open. And when the price is less than average variable cost, you decide to just shut down. Okay, that's how you break this up visually. Okay. And this is the Taco Tuesday region right here is the Taco Tuesday region. Okay. Okay. So let me give you a numerical example of Taco Tuesday. Okay. So let's say the price is equal to $5 a slice of pizza. Okay. Average total cost is equal to $10. All right. And average variable cost is equal to $3. All right. So remember from previous chapter, average total cost is equal to average variable cost plus average fixed cost. So if this is 10, this is 3, fixed cost is 7. Average fixed cost is equal to 7. Okay. And then quantity, let's make it simple and stupid and call it 10. So now let's compare two different decisions, shut down and produce. If you shut down, quantity is equal to 0. Okay. And total cost, well, average in this situation, we have quantity is equal to 0, and I have to give you fixed cost, and that one's kind of difficult to give you right now. It's probably better to do this right now. So let me do the production first. Sorry. So quantity is equal to 10. Okay. Fixed cost is equal to average fixed cost times quantity, which is 70. We needed that over here. And then total cost is equal to 100. 10 times 10 is 100. And then total revenue is equal to 50. And then profit is equal to negative 50. Okay. So if you produce, your fixed cost is 70, your total cost is 100, because 10 times 10 is 100. Total revenue is 50. And then profit is total revenue minus total cost is negative 50. So if you decide to shut down, the fixed cost we had to get from here, sorry, is 70. And you got to pay for that. That's your rent. So then profit is equal to total revenue minus total cost. Total revenue is 0 because you're not producing anything, so you don't get any revenue. Minus total cost, you have no variable cost, you only have fixed cost is 70. So profit is equal to negative 70. you could see if you shut down with this scenario here, in which price is less than average total cost, but greater than average variable cost. So like this scenario, if you shut down, you're losing $70. If you produce, you're losing only $50. So it's better to produce at a loss. Okay. Yeah, sorry about me starting here. I should have started on this side first. Okay, I'm going to clear this and move on. Now let's talk about a firm's supply curve in the long run. Okay. Let me write this all out. Okay. So a firm supply curve in the long run is the marginal cost curve where it's greater than equal to average total cost. Why? Okay. It's because how competitive firms make long run exit and entry decisions. Remember, firms can enter and exit the market freely. No one's forcing them to stay. No one's forcing them to blocking them from entering. They could freely enter and exit. So in the long run, if price is less than average total cost, what that means is that if we multiply both sides by quantity, total revenue is less than total cost, firms are making a loss. Then they'll just leave. Like, it's not worth staying here. I'm losing money. Okay. If price is greater than average total cost, then the firm is making a positive economic profit. Okay. Remember, multiply both sides by quantity, its total revenue is greater than total cost. In this type of situation, other firms will enter. Okay. And they will undercut each other. And in this type of situation, the firms will undercut each other, and you'll have a price war, and the price will be bid down. Okay. And to a point where we have here, where price is equal to average total cost, then there's no incentive to enter or exit. Okay, so let me talk about these two separate scenarios. There's quantity, here's dollar sign, and we're in the long run. So we only have one U, average total cost, and a J, marginal cost. And let's suppose the price is up here, okay? Price is equal to marginal revenue is equal to average revenue. In this situation where marginal revenue equals marginal cost, here's the quantity. Okay. And the company, here's the average total cost, they're making this profit. This profit right here is greater than zero. In this type of situation, so let's say the price is $5 a slice. And in this type of situation, if you're selling pizza and the market price is $5 a slice, and companies are making this killer profit of greater than zero, and Taco Bell will see this and they'll start selling pizza here. and they'll sell for $4.99 a slice. Then McDonald's will enter and they'll sell for $4.98 a slice. And this will keep going. And as more companies enter, the price gets bid down until price is equal to average total cost, which means profit is equal to 0. And on the flip side, there's quantity of pizza, $, average total cost, marginal cost, and here's the price right here. And let's say that's like $1 a slice. This is equal to marginal revenue, where marginal revenue hits marginal cost right here. This is quantity. And right now, this is average total cost right here. So right here, this is the loss. In this type of situation, some companies decide, nah, not worth it, and they leave. When firms leave because they're losing money, the remaining firms, okay, when some firms leave, the remaining firms, they get the customers, okay? And what happens here is when there's less stuff out there, the price gets bid up, okay? Because there's less, there's same amount of customers and less pizza for them, so they start bidding up the prices. And again, this continues until price is equal to average total cost, which means profit is equal to 0. All right. So we have this type of scenario. I'm going to clear this. Quantity. Here's average total cost curve and marginal cost curve. This is the individual firm's supply curve in the long run. They supply in accordance to the marginal cost curve. And then if the if the price, this area right here, is where price is less than average total cost, the firm shuts down. And this area up here is when price is greater than equal to average total cost, the firm produces in accordance to the marginal cost curve. This is the long run supply curve for the firm. Okay. All right. Now, given this, we just learned the long run and the short run supply curves for the firms, the individual firm. So now what we're going to do is talk about the short run and the long run supply curves at the market level. Okay, so let's do this. This is the short run market supply curve. So in the short run, you could have the following scenario. We'll assume there's two companies and they are the market. Why? Because I could only draw two companies here. So this is like Papa John pizza, and this is like Domino's, and they sell pizza in this city. Quantity of Papa John's, quantity of D for Domino's, and then this is the market. Okay. And I put big Q for pizza, for total market supply. Okay. All right. Papa John, they have their own special recipe and they decide to adopt their technology and pizza oven from a specific place. So they have an average total cost curve that looks like this, and an average variable cost curve that looks like this. Uh-oh. And a marginal cost curve that looks like this. Domino's, they did something differently. They picked their own secret recipe and sauce, their suppliers, and their pizza ovens. So their average total cost curve looks like this. Average variable cost curve looks like this. And marginal cost curve looks like that. Okay, so Domino's and Papa John's, they do different things. And so they have different cost structures. So how do we figure out what the market supply curve is? Well, in the short run, we know that the market supply curve is the marginal revenue curve that's above the average variable cost. That one and this one. So what we need to do is pick a bunch of prices and see how much each company would produce. So the first one we'll pick is this price right here. Okay. Let's say $10 a slice. At $10 a slice, Papa John's will make, I don't know, 100 slices of pizza per day. Domino's, they will produce, I don't know, that's 100. That looks like it's like 75. So at $10 a slice, total output by Papa John's and Domino's is 175. So right here we have point A, $10 a slice, 175. Let's pick another price. Okay. Let's pick a price here. $8 a slice. At $8 a slice, Domino's, they have, geez. Papa John's, they did their own thing, and they're producing like 90 slices of pizza. At $8 a slice, Domino's, they did something else, and they're producing 60 slices, less than 75, let's say 60. Domino's is already in Taco Tuesday land. If you guys see that, Papa John's is making money still. Positive economic profit. So at $8 a slice, the total output is 90 plus 60, which is 150. Let's just mark it right here, 150. That's point B. Let's do another one. Another couple. Okay. Let's do one right here. At $6 a slice, Papa John's, they're making around 90, I don't know, 70 slices. Domino's is making about 50 slices, 70, 80, 90, 100, 110, 120. So we have about 120 slices. Point C. I'm going to do another one. Okay. This is like $4 a slice. Domino's is now in, geez, Papa John's is now in Taco Tuesday land. They're making about 60 slices. They're still producing. Domino's at $4 a slice, it's below the average variable cost. So they shut down. They produce zero. So then at $4 a slice, we only get 60 because Domino's decides it's not worth it and they exit the market. So it's like right here, D. You do that for more prices. You connect the dots. And this is how you get the market supply curve. That is how the market supply curve is drawn in the short run for a perfectly competitive marketplace. That's the supply curve that we will use in the preceding chapters when we talk about supply and demand. You could see in this model where you have Papa John's, they did one thing, Domino, they did another thing. Papa John's thing that they did is more quote unquote successful, and they could actually take Domino's and they could put them out of business. How? Well, look, right here is break even for Domino's. They're still making money there. If Papa John's decides to price right here, almost less than that, like right here, I don't know, that's that's like $8.50 a slice. Papa John's will be making money. Domino's will start losing money. They're in Taco Tuesday land. They'll be losing money. So at the end of the lease, when all their fixed costs, like their lease is up, Domino's will just say, forget it. I don't need to stay in this business. Papa John's could take Domino's and put them out of business because Papa John's is more efficient here. Okay. So this is in the short run. This could happen in the short run where a bunch of companies, they're trying to figure out how to approach the market. Some do one thing, others do another thing. And you end up with a bunch of different players. And, you know, one company could be just purely taken out of business because what they did wasn't as good or efficient as what another company did. But let's see what happened in the long run if this is true. Okay, let's clear this. Long run market supply curve. Okay, in the long run, what we just saw in the short run is some firms could put other firms out of business just purely from picking different, you know, suppliers or pizza ovens or whatnot. And remember, we said there's no secret sauce, there's no secret recipes, there's no trademark trade name that you could uh, use laws to prevent other people from copying you. Not in perfectly competitive marketplace. That exists in other types of marketplace. We'll learn about monopoly and whatnot, monopolistic competition, but not here. So in order for, in my other scenario that I just put up, in order for Domino's to survive, they have to copy Papa John's. Okay. In the long run, all firms will copy the best way of doing business. Because there's nothing preventing them from doing that, they will all copy each other. All the firms in the long run will be identical twins of each other. We'll have the average total cost look like this. Goes to the bottom of the total cost curve, and that's the marginal cost curve. All firms will look like this. Okay, here's the quantity and the dollar sign. Okay. So how does a firm know how to produce and how do they how many firms are there, that will be determined through this model. Okay, like I said before, if the price is up here, firms are making positive economic profit, and the price will be bid down until we get to this point where price is equal to average total cost. If the price is down here, some firms will exit. Other firms that stay, they get more customers. And since there's less products out there, the prices will be bid up by all the consumers until price is equal to average total cost or profit is equal to zero. In the long run, we'll have the following situation. Here's this. Oh, oh, we'll have this following situation. Okay. In the long run, price will equal to average total cost right here. And every firm will produce Q star units in the long run. The supply curve, the long run supply curve will be flat like this. The dollar sign and quantity of pizza. This is individual firms pizza. Okay. Every individual firm will produce an identical amount. They'll all be sized the same. And in the long run supply curve will be a flat line. Well, how do we know how many to produce? It just depends on what the market wants, specifically what consumers want. For example, if a consumer's demand curve goes through here, this is demand, goes through right here, and big Q star, the amount that the market wants, is equal to 1,000 slices of pizza. And each firm produces 100 slices of pizza, and all the firms are twin identicals to each other, then we know N, which is the number of firms, will equal to 10. We will have exactly 10 firms, all producing 100 slices each to satisfy the demand. Okay, so in the long run, the big quantity is equal to N, the number of firms, times the production of each firm. Okay. We will also have a short run supply curve that we saw, which is like this. The short run supply curve is upward sloping, but the long run supply curve is flat. Okay. This is the end of my lecture for chapter 14 regarding competitive markets. I'm going to close the whiteboard and I'm going to share my notes. Hope you guys can see the notes. Why am I sharing the notes? Oops. Because after what I talked about, or the flat market supply curve that's on page 10, If you scroll down, you will see this section here. This will be covered after we do chapter 4. What is chapter 4? Supply and demand. After we do that, we're going to talk about fancy supply and demand, which starts at chapter 11. The fancy supply and demand looks like this, where you have two pictures, one for the firm, which we just see right here. We saw this already. Annotate. We saw this. We saw the flat long run supply curve, the demand curve, and I said, well, this is the short run supply curve. We saw this. Okay, but I don't want to get into this until we already talk about the quote unquote simple supply and demand model, which we will cover first. And then if we have time, we will cover this. Okay, close up shop. This ends the lecture on competitive markets or perfectly competitive markets.